All right, now that we know how we can change our position, or a couple ways we can represent our change in position, let's start talking about the other aspect of motion, which is time. So when we talk about time, there's two ways we can look at time. We can look at what time is it, or look at how much time does something take. So we're looking at what time is it, we're looking at what we call clock time. So let's say I leave my origin at 12:15 p.m. That's the clock time for the standard place where I'm at. Let's say where I'm at Arlington Heights. So it's 12:15 at Arlington Heights. Let's say I reach McDonald's at a clock time of 12:45 p.m. So in physics, we're not as interested in clock time as we are time interval. Sometimes we call this delta t, or how long does it take to get from where I started to where I finished. So in this case, my change in time, my delta t, which is always my final minus my initial, would be how much clock time elapsed. So I got there at 12:45. I started at 12:15. So we could say 30 minutes is my clock, or my time interval, my delta t, how long it took. Now the standard units we're going to use though for time are seconds. So sometimes we have to do a handy dandy conversion. So to go from minutes to second, if it took 30 minutes, we know that 1 minute is comprised of 60 seconds. So we could do the 30 times 60, or say that it took 1800 seconds. So we're going to be doing conversions to meters and conversions to seconds. All right, well, if I know where I am in space and I know where I am in time, another useful thing is thinking about the rate. How fast did I go? How long did it take me? What was my speed? What was my velocity? So these are the last two introductory terms that we're going to talk about in this video. So we can say speed and velocity. Now in the normal everyday vernacular, these are typically used interchangeably. I have a certain speed or I have a certain velocity, but there really is a difference, a subtle difference. So now we're talking about averages here. Average speed and average velocity. This is not a division sign. I was underlining speed and then I wanted to clarify to make sure that it was average. So that's not speed divided by average. That's just average speed, average velocity. So we have speed. Think of a speedometer. Right? What a speedometer tells you is how fast you're going in any given time. But it's always a positive value. It has nothing to do with direction, whether I'm going to the right or to the left, or my average over a given amount of time. It just means how fast. So it's taking into account the distance I traveled over a certain amount of time. So d divided by delta t, our time interval. Velocity, on the other hand, has to do with my change in position over a certain amount of time, my delta x over delta t. So let's just take our example here and let's look at the speed, the average speed versus the average velocity. So my distance traveled when I went to McDonald's and then back to Frankie's house was 6.6 kilometers, and we can do kilometers per minute to keep it simple. And it took me, well, I guess we didn't say how long it took for me to get to Frankie's house. It took 30 minutes to get to McDonald's. Let's say it took another hour to get back to Frankie's. So the total time was 1.5 hours. Okay, so my time interval was 1.5 hours. Okay, so my average speed there, I should have my calculator handy. Is my speed average is 4.4 kilometers per hour. Now my average velocity, on the other hand, is my change in position over time. Well, my change in position was negative 1.8. 1.5 hours, which is negative 1.2 kilometers per hour. Well, how could I have a negative velocity? What that means is I spent some time moving to the right and most of my time moving back to the left. So if you take that into account, overall my average velocity was moving to the left because my change in position was to the left. So notice that this negative implies that there's a direction with velocity. So average velocity, average speed, two different things. One is dependent on distance, one is dependent on my delta x, my change in position. Now, I did say here, written down here, I had the standard units for velocity being the meter per second, and we are in kilometers per hour, so sometimes it's helpful to do the conversion back and forth. You might solve for your answer and then convert later, which is fine. So let's take this one. Let's take my average speed. I'll go a different color here. And let's convert from kilometers per hour to meters per second. So 4.4 kilometers per hour. I want to go from kilometers to meters, so I know that 1 kilometer is 1,000 meters. That gets me into meters. And I know that 1 hour has 3,600 seconds. Something to definitely know. How do I know that? Well, to go from hours to minutes, minutes to second, 1 hour, 60 minutes. 1 minute, 60 seconds. So 60 times 60, 3,600. So 1 hour is just 3,600 seconds. We'll use that one a lot. So I have 4.4 times 1,000 divided by 3,600. So my average speed in meters per second is 1.22 meters per second. And there's an introduction to time intervals versus clock time, average speed, and average velocity.